And we're live.
All right, welcome back, everybody. Thank you again for joining us. Uh, Another great session is in the making here on the supply chain working group. And today's topic is going to be tier supply chain system. Your hosts today are going to be Dana Jensen from Agility Prime, DoD, David Ibarra from FAA, and myself, PK from NASA. The three of us will be working with you and seek your inputs on different aspects. We have a great speaker lined up today that my good friend Dana is going to introduce, and we will talk a little bit about what we have in the making in terms of the tier system and what we mean by that, and then go to our distinguished speaker. So next slide, please. You can continue to provide the questions through Conference IO, and you can also watch on the YouTube. If you only wanted to be in the listen mode, you can use the chat function in the Microsoft Teams to interact with each other. But if you wanted a wider discussion of your question and response from the moderators as well as general information, then I would suggest you add your questions on the Conference IO. So if you're, again, platform for MS Teams to be part of this and be very active as much as you like to interact with each other. Conference IO is to put in the formal questions and get responses. You can use raise your hand function on the Microsoft Teams if you wanted to ask a question to the moderators or the speaker, and that's another way you can interact with us. So we would like to be as interactive as possible. There's already been few questions, which is exciting to see, related to the request for information as well as the maintenance, repair, overhaul. So we are looking forward to continuing the question answers on the Conference IO and addressing those and making sure that what we do here is highly relevant to your needs and it meets the community interest as well as the support that is needed as a group of supply chain experts and the enthusiasts and stakeholders in this. You can leave off the cameras, to preserve your bandwidth as needed. Again, raise your hand in this Microsoft Teams to ask a direct question through voice. Use the Conference IO for a documented questions with the record that stays there. It will answer you. If not, right away it will get answered. And then if you just want to listen in, you can go to the YouTube as well. Next slide, please. Okay, so I'm going to start this and then give it to Dana. Basically, today's topic is focused on creating a tier system. As we talked about in the past, the tier system for advanced air mobility doesn't quite exist yet, and we are in the process of figuring out how to establish that for everybody's benefit. As you probably know this already, the tier system for larger original equipment manufacturers, as well as the car industry, aircraft and car industry, has evolved over decades. It was a time when each manufacturer used to deal with each supplier individually, and that was just too onerous. So now doing those interactions and doing aggregate planning and coordinating that was not an easy task. It's a little bit easier now with the digitization. Nonetheless, the tier system does allow you to have higher efficiencies. Now, the only some of the drawbacks of tier system is it reduces your transparency into the lowest possible tiers because you tend to only interact with the next tier up and down. So that's the challenge with the tier system, obviously. So However, that can be alleviated through a digital means. So this is one of the advantages that we would like to propose, is that once we have a digital electronic exchange platform as well as this kind of a structure, you have a much more elegant way of interacting with your nearest tier for efficiency, but also you have access to what's going on in the downstream and upstream tiers as needed or as authorized. So typical tier system, this is a very simplistic view, but it comes from Trust Vista Financial Services package. It's online all over the place if you wanted to, but that basically gives you the multiple tiers from engine manufacturers, landing gears, wings, fuselage is a conventional one, and then goes into the parts that are connected into those. So this is how the current system is set up. Now I'm going to hand it over to Dana, who will continue the discussion, and I think we're going to suggest a next tier system for AAM, and then go on to the next step. And so next slide. Okay, Dana, you want to take this on?
Of course. First of all, thank you very much, PK, and to NASA for hosting another monthly event here. I think this is going to be great. I'll admit, I have some experience with the dynamics of supply chains, but I have very little background in exactly how supply chains emerge. And I know, PK, you've taught this sort of thing in an academic setting before. So I'd like to say, maybe more so than in normal meetings, I'm going to be in learning mode about exactly how things are going to evolve. That said, I mean, I think there are a couple places here where we can see at the tier one level, especially, some major differences between, the traditional aerospace supply chain and the AAM supply chain. The first obviously is that upper left box, which is the propulsion systems. I think everybody assumes one of the advantages of the AAM vehicles is going to be that their propulsion systems are simpler. I mean, once we get to know how they work, but the motor has two moving parts as opposed to the elegant complexity of a turbine engine. So you could expect that perhaps a smaller proportion of the overall cost of the vehicle is going to be taken up in the propulsion system, with the possible exception of the batteries, right? We're not really sure where those will spec out in terms of cost, and this is another place where scale is going to be a huge factor. And it's a reason, in this group especially, we want to try to encourage the scaling of battery technology as quickly as we can. That is to say, battery technology optimized for AAM. I mean, obviously, the automotive industry has been building batteries for years now on big scales, but they aren't really optimized to AAM the way we would need them to be. So we're going to either be looking at modified chemistries and arrangements of automotive batteries, or novel batteries coming specific to the AAM market. The other place that's a little different, I think, is the wings, right? So, in the prior slide, you could see wings were a whole tier one category. When a new aircraft is in development, it's always a milestone when the wing is attached, right? And you see the testing to failure of a wing. They always show the huge wing on a rig, and it's a major part of a tube and wing, modern day commercial aircraft. That's not to say that it's not going to play a major role in some eVTOL designs. I mean, obviously, if they're in wing-borne flight, the wing needs to meet the right load factors to support wing-borne flight. But multiple designs don't have wings at all, right? The sort of multi-copter arrangement. So the relationship between the importance of the wing and the vehicle as a whole, I think it's going to be relatively less in the AAM space. One of the things, if you go all the way to the right, you start looking more at the raw materials. Obviously, there's sensitivity around the rare earth metals down in the bottom right. I mean, right here, they're placed in with electronics and avionics. They could just as easily be placed in the upper right underneath the propulsion systems, right? Because the neodymium permanent magnets in the electric motors are, always something that people are concerned about. So, rare earths can be sprinkled along, maybe not the interiors line, but, anything electronic really at this point. So one of the things I just wanted to point out, without belaboring, all these categories, is, the blue lines that connect these boxes are business relationships. And we don't want to lose sight of the fact, because if we treat these as boxes, which we're wont to do in this kind of analysis, I came from the capital markets, and I was always very cognizant of the state of all the business relationships that I was trying to maintain. And so those lines connecting these boxes are very, very important. You think of it in terms of leverage, right? If you've got one big customer as a supplier, right, that customer is going to have more sway over your business decisions. And likewise, if I'm a supplier and I know that I'm, one of few, I'm going to be able to exert leverage over my customers, right? And obviously the highest expression of leverage, imbalance is a sole source, sole customer or sole source sort of situation. And so one of the things we want to try to do is develop a supply chain that mutes leverage imbalances. It keeps them in check. It makes for more efficient price discovery, right? And so sometimes, if you look at these diagrams, you might not be able to tell. Oh, okay, well, there's only one company that supplies, seats, and so they can move the entire market, and they can inhibit price discovery because they've got the ability to basically set prices themselves. And so you think in terms of the current aerospace supply chain. If you look at the margins, right, the margins at the OEM level, I mean, they vary, and I'm sure they're not, what they were, but, historically in the, 8% range, maybe 10. But then as you move down the supply chain, the margins get bigger. In tier 3, for example, I mean, I think historically margins are anywhere between, 8 at the bottom bound, but over 20%, So I think, as Uma will probably point out, there's consolidation happening at some of those tiers, partly at the behest of the OEMs and partly just organically. But I want to highlight the fact that we, as NASA and the Air Force, are cognizant of the fact that these are business relationships between the tiers, and we want to be sure that we understand the subtleties of how that works, because I think in some way it will inform the modeling and simulation that we do later, right? It's not totally mechanistic. There's also an element of relationship in there that we need to try to capture. So with that, if we could go to the next slide, I will introduce our guest speaker.
So, I mean, just one thing, then I was wondering if David wanted to add, sorry.
Oh, yeah, sure.
If David, if you wanted to add anything, perspective on the tiers. There's many thoughts here, obviously, but David, if you wanted to just quickly give overarching thought, and then we can also connect back after with the audience after the Uma's talk.
Well, just to let everybody know, as a caveat, since my background prior to FAA, I did come up from the manufacturing world on large aircraft, commercial aircraft, Part 121 aircraft. And so I'm very familiar with the traditional tier system. And with Dana, I could relate when you talked about the wing aspect of it. It was always a big deal when the wing was attached to the fuselage of the aircraft. So it was a milestone. But again, with that caveat, that my background is maintenance and avionics systems on both general aviation and air carrier aircraft. I'm not involved with the FAA side in regards to the supply chain, although a lot of the parts and components that get certified would be under the Aircraft Evaluation Group, or AEG. So they work in concert with the manufacturing companies to be able to get these parts and components reviewed and certified, along with the Aircraft Certification Office. But me providing my opinion on this side of it, since from the manufacturing world, this is going to be all, as we see, all brand new with the VTOL aircraft, and a lot of the systems and a lot of the structure that's in place now will serve as a great platform to be able to build upon on these new aircraft. So as long as we remain open-minded and sometimes maybe think outside of the box, to be able to come up with new ways to be able to track this and then make it come to fruition. But ultimately, excuse me, when we want to approach these parts and components to certify them, we would have to approach the AEG and the ACO and the MRB groups, maintenance review boards at manufacturing level for the initial certification.
So Dave, I know we probably say this a lot internally amongst our team here, but I just want to say again how thrilled we are to have FAA involved and taking a leading role in what we're doing here. I think it really grounds us in reality, right? And you know, on one hand, you want to understand that these are businesses and how those relationships work, and on the other hand, you want to understand how do they get from where they are now to being, you know, functional vehicles, both from a type certificate and a production certificate standpoint. So again, just really thrilled to have FAA on board and looking forward to working with you guys going forward.
Yeah, and like I said, for those people that definitely approach the FAA with the aircraft evaluation group and maintenance review boards and the aircraft certification office, because they're the ones that are involved with the initial certifications of any parts or components or even the aircraft itself. So it starts from there. So once they do their review and they receive the urban aircraft receives their type certification, now we as flight standards, because I represent the flight standard side of it, we deal with the renewal of certifications, all maintenance and inspections, avionics inspections, renewals, again, renewal certifications. So we get involved with that.
Well, that's a good point, and I think you mentioned your background in MRO type activities, and this is another one I think we could devote a whole session to just how does the MRO ecosystem evolve around these new vehicles, right? And I think the plan for some of the developers is that they're going to do it themselves, but you know, I wonder if maybe involving, you know, some third-party MRO firms, and I've spoken to a few already who are, you know, chomping at the bit to get involved once these things start flying, and already have, you know, operations at airports all across the country. So that's an interesting question, especially when you consider that, you know, in the commercial space, the MRO market revenue is, you know, something like 2/3 or 70% of the size of the aircraft production market, right? So there's a lot of money to be made in working on MRO down the road.
Exactly, and a lot of people don't realize how important that is, because that's, when you see the bigger picture, it's literally the backbone of aviation, whether it be current commercial operations or even the new urban aircraft that are coming on board. So it's literally the backbone.
Yeah, absolutely. Well, with that here, I'll shift gears a little bit and introduce Uma. Uma Subramaniam is the CEO of Aero Technologies, a next generation premium air carrier for the experienced economy. And pardon me for reading here. I don't usually do that, but I think this is worth reading. Uma joined Aero in March 2019, and in just 12 months built an air carrier with operations in the US and Europe. In its first summer of operation, Aero was gross margin positive despite the global pandemic. In addition to her work at Aero, Uma is a thought leader in next generation aviation, especially urban air mobility. She sits in the advisory board of Volocopter and is a venture advisor to UP Partners, a pioneering air mobility fund. Prior to Aero, Uma was the founding CEO of Voom Flights, an Airbus company, which built the world's first urban air mobility network with helicopters, and thus laid the foundation for electric VTOL networks in 3 years. Voom Flights launched in Sao Paulo and Mexico City and flew thousands of passengers on intra-city routes. By way of background, Uma holds an undergraduate degree in aerospace engineering from the University of Michigan and an MBA from Harvard Business School. Uma is passionate about aerospace and has spent the majority of her career working in the industry, first in the space program at Northrop Grumman, then in M&A at Rolls-Royce and Ultra Electronics, and most recently at Airbus. So Uma, with that, I'll hand the floor over to you and look forward to what you've got to bring us.
Awesome. Thank you very much, Dana. As Dana mentioned, I have worked for a lot of folks up and down the aerospace supply chain. And I've worked at the OEM level. I've worked for a tier 1 engine supplier. I've worked for a tier 3 and tier 4 parts provider. And I've done a lot of thinking about the distributed tier 4 supply chain, particularly looking at it from the SDB perspective. the small disadvantaged business perspective. But today I want to have a conversation with you from the perspective of an operator. And as Dana mentioned today, I am running an airline against perhaps my better judgment, but it is very interesting to be on the other side of the coin. So my current company, Aero, operates a fleet of retrofit ERJ 135s with AE 3007 engines. And it's very interesting being a small operator, having to go back to the major OEMs as a customer now. And you realize that there's a lot of, there needs to be a lot of changes in how operators and their customers work together if ever we're going to have a scale UAM system. So I want to come at this problem from that perspective, from the perspective of an operator. I also, when I was at VOOM, we built an urban air mobility network for Airbus that came out of Airbus's Silicon Valley incubator, A-Cubed. And when we were at A-Cubed, we did a lot of work on how does a system for urban air mobility become mass market? Meaning, we are seeing, I believe today there's over 250 concepts for electric VTOL aircraft. And they're all kind of various degrees of cool, right? Some have wings, some don't have wings, some are vertical lift, some are tilt. There's a whole bunch of different configurations. Some are short takeoff and landing aircraft. But what I don't see from anyone is a thought around how am I going to take my vehicle from a prototype to an industrialized product, and how am I actually going to offer a system at scale that enables urban air mobility to truly be a transportation mode for a mass market. So I want to start from that perspective and ask that question. I will say in advance, massive disclaimer, I don't have a good answer. But what I've tried to do here is actually articulate what I believe the problem is. And I think I have some ideas of how you might start thinking about it. But one of the things that we need to think about as an industry is we want to avoid what's happened in the commercial aircraft space and really create a market that is broad and dynamic and enables a lot of people to a lot of different vehicles and configurations to operate. But we need to radically rethink how we do supply chain. So that's the context for this conversation. All right, Brian, can you move forward? So the reason for having this conversation now, right, is that as we look at the last 10 years, it has been a period of enormous innovation in aviation. On the right is Project Vahana, which was another project that went through the A-Cubed incubator and got to a flying electric VTOL prototype. But the innovation has been not just in the urban air mobility space, right? There's been new concepts in supersonic flight with Boom. There's been a lot of progress on the electric aviation space, Zunum and Eviation and Ampere. And there's a lot of progress happening with new companies in this space. However, none of these companies have yet gotten to a point where they're a production scale. Next slide. At the same time, over the last 10 years, it has been a period of enormous consolidation in the industry. So if you look at M&A transaction volumes in aerospace and defense, in 2018, total deal values exceeded $30 billion, and there were 290 aerospace and defense transactions in that year alone. If you look back over the last 10 years in the aggregate, we're getting almost close to $1 trillion in deal activity in the M&A space in aerospace and defense. And there was one year in particular, I think it was 2015, where there were a massive amount of transactions. And what this tells you is that the supply chain is becoming very, very tightly integrated. Next slide, please. So as we look at this is a chart about the landscape in the defense space, and particularly in the tier one, in the OEM and tier 1 and tier 2 supply chain. Whereas we had, 20 years ago, multiple dozens of providers and options. Today, we really only have 5 OEMs that are operating in the aerospace and defense tier 1 and OEM and tier 1 space. As we know, Boeing acquired McDonnell Douglas, Lockheed Martin has acquired L3, and GD Space and GE Air and Northrop Grumman has acquired TRW. And what this has done is that it's created very few vendors and very few vendors at the next level in the supply chain. If we go on to the next slide, the problem is even worse in commercial aerospace, right? So this slide is deliberately not exhaustive, but if you look at the massive amounts of M&A that has happened, and Dana talked a lot about what the margins look like in the different tiers of supply chain. Fundamentally, we have two OEMs above 100 seats, two OEMs below 100 seats in the commercial space. There's a whole bunch of players in the GA and corporate jet space, but fundamentally, we're looking at a very, very concentrated market. If you look at the tier one suppliers in the last 5 years, UTC has acquired pretty much everyone, right? And Safran has acquired pretty much everyone else. So Rockwell, Collins, Goodrich, BE Aerospace, Zodiac, they're all rolled into these two companies today. And so when you're an OEM, when you're an operator, so I'll give you an example. So at Aero, we are in the business of operating legacy aircraft, and we want to do some retrofits on our aircraft to take them back to a 16-seat configuration. We have to get the seats from one of two suppliers, Zodiac or BE, now Safran and UTC, or Raytheon Technologies, they're called. And what that does is that creates very few options for us as the operator, and we have to go back to a very, very limited supply chain. And we know, and Dan and David talked about it, that to the FAA, what matters most is safety and ensuring that the system, that the operators and the products, maintain form, fit, and function equivalency. But what it does from an operator point of view is it makes it very, very expensive to operate. And what we're seeing now, particularly in this post-COVID environment, is that these total operating costs and total maintenance costs of these platforms are so high that when these companies run into financial difficulty, there's very, very little margin for them to operate. And that's something that we need to think about as we scale, right? So this is the end result of 100 years almost of development in the aerospace supply chain. But what we need to think about is how do we take, as we're going through this UAM development phase, how do we go back to a federated supply chain system in the likes of what happened in the early aviation commercial ecosystem? Okay, next slide. When you think about the enormous margins for the tier one, and Dana pointed out tier one, tier two, and tier three suppliers, you also stifle innovation, right? It is not cost effective for Safran to produce a run of 10 of engine seats for 10 shipsets, right? And so what you see is that it is very hard to get these major OEMs to do small volume runs of anything. And so when you're in that position, when you're an operator and you have very, very little negotiating leverage, when the supply chain is so concentrated, you end up not being able to innovate. The innovation is, do you want purple seats or do you want red seats? And you end up with not much variance between products. And that's why today, as you look across the global fleet of aircraft, there's very little variation in product, right? British Airways' business class now has a door, which is great, but it's not like a radically better product. And so as we think about UAM and as we think about this industrialization process, the importance of maintaining a wide and varied supply chain becomes increasingly prevalent. Okay, next slide. So why should we care about this consolidation? Why should we care about supply chain at all? Next slide. So when I was at Airbus, we did a lot of analysis about how do you make urban air mobility viable for a mass market audience. And we came at this problem from the perspective of you have to believe that urban air mobility, an intracity urban air transportation network, can compete with other options for mass transit. If you run that assessment, so the way we did this analysis was we looked at we took one typical 15-minute journey. We actually looked at London and we said, from London Heathrow Airport to the city center of London, what are the various options for premium transport and how much do they cost? We then mapped, you then get a price for a representative 15-minute journey. If you then take that representative price for 15-minute journey and tack on a margin for the operator, call it 20%, you get to a price that is the total revenue per passenger for that operator. if you then make some simplifying assumptions, so we know that today's battery capacity limits you to vehicles that are for maybe max 6 passengers. So that is, so the 4 packs or the 6 packs times that price per 15-minute journey gives you the maximum revenue that you can do in any 15-minute window. Multiply that by 4 and you get the maximum revenue that you can do in any 1 hour period. From that, as we know in aviation, most of our costs are accrued on an hourly basis or on a cycle basis on the engine side. So if you have your maximum revenue on an hourly basis and you assume a certain profit margin, you get down to a total operating cost in order to build a system that is competitive with today's mass transit. Even if you believe that the system is going to be 2 or 3x the cost of today's mass transit, you start to quite quickly diminish the size of your market at scale. And quite quickly, you get to a system that is subscale, right? And in a subscale system, you end up in a world where the rich people are basically flying over the poor. I get this question a lot when I talk about urban air mobility to people that are not in this space. How do you avoid a system like what we have with today's helicopters where only a very, very select few people can afford to fly in that space? Well, the answer is that when you're thinking about developing the ecosystem in the aggregate, you think about total operating cost as an input rather than an output, right? So today we're seeing all sorts of really cool and crazy designs. But those vehicles, when you actually come to industrialize them, they're going to be unaffordable, right? And they're going to yield a system where, again, you have a few people able to access that system. And so a number that I realize that the text on the right is very, very large, but I think it's very important because this is the calculation. I'm just going to give you the answer that we calculated, which basically said that in order for a system to be mass market, right, the total vehicle operating cost, including fixed and variable costs, right, needs to be $6 a minute or $360 an hour, which if you operate an R44 for 800 hours, you get to a number relatively close to that. So it's not unachievable for an air system, but it does require us to think about systems at scale. And it requires us to think about total operating costs as an input to this equation as we think about building out these systems. So if you start from a total operating cost perspective, and then you back out quite quickly or you use kind of a conventional, the conventional analysis from Conklin and De Decker, which gives you a breakout by cost bucket from a variabilized perspective, you can quite quickly assign costs to different portions of the vehicle architecture. So Dana showed a chart listing all the various subsystems that you may see in an electric VTOL aircraft. You can quite quickly go and assign or calculate what that system cost from an operating perspective would need to be. And then you make assumptions. If you know what the system operating cost is going to be, you make assumptions. Assume that you sell 1,000 vehicles through life. Quite quickly, you get to, say you sell 1,000 vehicles through life and you generate that same revenue in the aftermarket, right? As we know, today's OEMs typically sell their product for a loss. They make the money back 2, 3, 4x on the aftermarket. Even if you use those assumptions, you can quite quickly get to what the total amount of money you're allowed to spend to industrialize your system is. And then you realize, okay, we need to have a radical rethink about what this market needs to look like. Next chart, please. Bree, next chart.
Sorry, I'm on the next chart. Can you see it, Uma?
No, I can't. My screen seems to be frozen. Hold on.
Also, as we are taking, can you all please check the mics except for Uma's? There may be some open mic accidentally. Thank you.
So a quick, so I can see the charts on my end. So if you look at this next chart, right, this was a this was a 2-second search on Google for comparative eVTOL architectures, right? You end up with a bunch of architectures that look quite different. But actually, as Dana's chart pointed out, the subsystems are all quite the same, right? So pretty much every system has an electric motor. It has a rotor in a different configuration with a different look and feel. But generally, you're talking about the same systems. It has some sort of landing gear, probably skids in the case of the Cora vehicle or the Kitty Hawk vehicle, wheels. In the case of the opener, it just kind of lands on its belly. But in general, like all of the subsystems are the same. And if you look at all of these vehicle types, right, so these are all in the prototype phase. And I know, PK, you talk about the 3 phases of aircraft development. When you are in the kind of prototyping phase, you typically don't think about what does the industrialized view of this look like, right? And we know, we know that we need to get to, in order for the system to be a mass market system, we know that we need to get to commercial aircraft 10 to the minus 9 levels of redundancy. So you can quite quickly figure out which of these, like in any given architecture, which of these things are a single point in failure, and realize that they're going to need to be dually redundant, right? And you end up coming up with 1, 2, 3, 4, maybe 4 architectures that are viable and potentially scalable. The other piece is, I know Kirsten talked about this a lot at your session last month. I've been trying to help a few electric VTOL OEMs raise money. And what is very, very clear is there's a ton of capital in the sort of $0 to $25 million space, where a lot of people are getting a little bit of seed capital to test their ideas. However, when they then come back and try to raise a growth round, it gets materially harder, right? So trying to raise your $50 to $150 million round is very, very difficult unless you either have a billionaire backer to start or are early to the game, like some of the people that have successfully raised money recently. And if you believe that to be true, right, quite quickly you realize you're going to end up from this list of 250 OEMs, maybe we get 5, right? Plus, like what the today's aerospace OEMs are putting out there, Bell and Sikorsky and Airbus and Boeing. But we're not going to end up with hundreds of different vehicle types. There's just insufficient capital in the space. So you realize, like, okay, we need to think about how we can create some sort of commonality and or best-in-class expertise in order to actually create a system that has variety in the supply chain. So my point from all of this is that it's billions of dollars to industrialize any product. There are not multiple billions of dollars and not hundreds of family offices that are going to fund something like this. So we're going to end up with 5, maybe 10 OEMs in the UAM space. And if that's the case, then there's a ton of product commonality already. All the subsystems, like there are variants on what the product looks like in various subsystems. But ultimately, there has to be a way that we can think about collating capability and building best-in-class technologies that enables this system to scale, right? Because what we know, at least what the 7.3 Max has taught us, is that we're not going to be able to rush a product to market. We're going to have to actually prove that these vehicles are safe and redundant and that the systems work. And what I hope does not happen is I hope that we're not mandated to use aerospace grade parts, because we're going to end up back with the same, 6 suppliers that we buy parts from today. But there has to be a holistic rethink about this, and there has to be an approach taken which enables kind of best-in-class capabilities to be aggregated in some sort of way. Next chart, please. Are you on the next chart, Bree? I can't. It's not changing on my phone. And so my conclusion here is that unless we radically rethink the supply chain and spread subsystem development costs across multiple platforms, we're going to end up with a system that looks very like the industrial landscape that we have today. So what I'm excited about with this NASA and DoD conversation is that we're thinking about it early. And what I would ask is that we think about it early, but from a total operating cost and from the perspective of an operator that someday wants to run a scale system. That's the end of my sort of prepared thoughts. I started this conversation by saying I don't have an answer, which I don't. To be fair, I haven't put that much thought into how we would get to that outcome, but I think that there is something that it's a piece of analysis that needs to be done. And we can quite quickly get to what the industrialization costs by subsystem need to look like. And I think that's an interesting starting point. And maybe we go out and we create a federated network of aerospace grade suppliers that can provide motors and battery packs and various configurations. So that's as far as I've gotten in thinking about this problem. But I am happy to take any questions, answer any questions from the perspective of an operator that I can.
Well, Uma, thank you very much for that.
Yeah.
That was.
Sorry, Dana. Go ahead. No, please go ahead.
Oh, yes, sir. thank you very much for that. I think it's good to hear kind of maybe a more bold message about how the supply chain should go, because I think we you know we don't want to spend too much time smiling and nodding and agreeing with each other over all these things, and there are going to have to be some tough decisions. I mean, it immediately jumps out, kind of what would the mechanism be for spreading that cost off across, several potential customers. I mean, I do know one, they're not an eVTOL OEM, but they are a developer of a big new system who's actually funding the development of a new engine with one of the kind of usual suspect engine manufacturers. And I mean, as you can imagine, that's an incredibly expensive proposition. But I mean, it makes you wonder if there were a way to pool resources, even if those resources went into, one of the usual suspects, if at least that gets something that comes out certifiable faster. Although then I also wonder if the idea of strategic patience isn't important here, because in order for new suppliers to enter the market, they're going to have to build things that can be certified, and that's going to take time, right? So you don't want to be in so much of a hurry that you just default to using the existing aerospace market because you want to be first to market, right? That maybe that patience of hanging back and developing, cultivating new suppliers is worth being later to market. That the first mover advantage isn't necessarily the be all end all here.
Well, I think that's a great point, right? Because like if you look at Airbus was arguably 30 years late to the jet age in an aggregated way, right? So the A300 came out in the 70s after the jet age had been going for 25 years, and now Airbus has 51%. Well, depending on how you cut the market, 51% of the commercial aircraft market, and so it's an interesting, it's a very interesting point. Like actually letting some of these companies go through and then rejoining the fight later is a very viable approach. In fact, if you'll notice, the people that worked at A-Cubed on urban air mobility, none of us are in that space at the moment, because I think we all realized we ran this analysis and we're like, oh, this needs a radical rethink, and then we kind of all are doing other things, and the idea is that we'll come back to it in 5 years, is because it probably will not have moved on to take a very skeptical worldview, right? I'm excited about urban air mobility, but having run a business in this space, do I think it's viable as a business in the next 10 years? Probably not. And for all of the reasons that we're talking about here, because the reality is that rushing a product to market is going to be hard. And a lot of the OEMs that I talk to are like, oh, well, we'll just use the automotive supply chain. But then you end up with all of the problems of just, maybe David can speak to this, but I'm not sure the FAA is going to be super, super jazzed about letting an aircraft through that's only been, that's built entirely of automotive parts. So I just think that it's not, there's a lot of excitement about this early stage, product development, but it's not clear how it's going to take the next step into the phase 2. And, and then this whole argument could go out the window if China kind of creates an open system and allows vehicles of various types into the market, then maybe the market opens outside the US, and then it's a different story altogether. And then, that is the trial market for where things get accelerated. But if we really want the US to be kind of the nexus of the development of urban air mobility, we need to think about this problem in some sort of integrated way.
Dave, I noticed you have your hand up. Want to take the floor?
Yeah, just real quick, it's a question for Uma. I understand the concerns and also some of the I'll say opportunities to grow for the FAA to be able to get past regarding the supply chain. But my question to you is this: as a manufacturer, obviously you've looked at the battery technology that currently exists. Has any of the manufacturers that you know of, including yourself, looked into expanding or improving on the battery technology? Any R&D that's going on to improve the battery technology?
So actually, our other point of skepticism, not just on the industrialization cost, is actually battery technology. The best in class products that we see today either have a swap the battery system or have a, you have to land and then there's this like aggressive recharge of the vehicle. And the aggressive recharges we know will kill battery life. And then you're left with all of this remnant lithium ion, material sitting by the wayside that you have to do something about. So it's just today's battery technologies does not really enable eVTOL at scale, right? So that's why you're seeing other architectures or hybrid electric propulsion systems. And I think like this really becomes viable when we take the next leap in battery technology. So there's some interesting companies in Silicon Valley, Sila Nanotechnologies, which is working on better anode and better cathode materials. That is quite interesting, but this is really a chemistry problem. And it's like about really fundamental chemistry and a radically better propulsion system than a lithium, whatever, battery pack, today's battery packs. And so I think that's the other kind of major leap, because what we're seeing right now is sort of incremental improvements in battery technology, but not the radical leap that you need to have a really, really power dense system.
So you feel, in your opinion, then that if the battery technology gets improved, then that would expedite the evolution of urban air mobility much more quickly?
100%. I think that's a key. That is a key barrier to it truly being scaled, because right now, like a system where where you land and you swap out the battery pack and you have to recharge the battery pack, it's clunky and it's very labor intensive, and it's not really scalable, right? In that sense, like you don't end up with a fully autonomous fleet or this Uber vision. And I have not yet seen, and I've seen a lot of eVTOL companies. I've not yet seen anyone that's cracked that problem.
Yeah, we see this clearly also with the small UASs, where they're coming up with nest systems where the drone comes in, lands in the nest, the battery gets swapped out quickly, and then it takes off again, which again takes time. So now you supersize that into urban air mobility. The viability there, it makes it tough to actually make it operational.
One thing I'd also point out is, certification of batteries. If you look at what the highest, energy density of any battery currently certified, I believe it's in the 787, the Dreamliner. It had its lithium-ion battery pack problems at the outset. It looks like those problems have been resolved, but now somebody out there can correct me if I'm wrong, but I think that's a battery that's somewhere in the 50 to 70 watt-hour per kilogram range. And, we've got batteries now that have densities, 5 times that. But, if you look at that variable, you're going to say, well, what'll get certified is something around, 20 to 50% of what we can do in a bench environment, with a battery, not, just at the cell level, not at the pack level. And so, again, it's a question of what gets certified. So even if somebody, at university setting can produce a 500 or 600 watt-hour per kilogram battery, by the time you put it in a pack and then ask to get it certified, I mean, you're going to be dealing with energy densities more along the lines of kind of middling stuff that we've got available now.
100% agree.
Well, keep in mind also,
Which is why I think this is actually a chemistry problem, not a pack design problem. Like you need something else other than lithium ion, right? It needs to be something else.
well, keep in mind also, though, regarding the certification part of it, you have OEMs out there producing these batteries and to set specifications. But the that, say, an aircraft manufacturer acquires that battery and adds it to ultimately the type design of that aircraft, then the aircraft manufacturer in essence, owns that design. So if something happens to that battery, it goes back to the manufacturer to either research, replace, or whatever the case may be, based on whatever contract was made with the buyer. So, so you have battery OEMs, and then to meet building batteries to set specifications to the aircraft manufacturer. So it goes back to the aircraft manufacturer. So there's 2 areas that is there, what's the right word for it? Is there requests out there for better battery technology? Because right now, there's a lot of OEMs out there that they're creating all this great battery technology, but does it get to the point where the FAA can say, okay, let's look at it? And is there more requests saying, give us more battery technology, better battery technology? So it's just something to look at in research.
Dave, one avenue that we've been looking at recently in the Air Force is, we've been talking to Formula One. Now, Formula One does a lot of things related to modeling and simulation and digital twinning that's really compelling because, putting a lot of resources into it and have over the last decade. And so they're pretty advanced, and it's of necessity because, they have to model minor tweaks to their vehicle in a week between races, and they don't always have a lot of time on the track. But the other place that they're doing some pretty amazing work is in Formula E, which is their all electric race circuit, right? And these are batteries that need to run at C rates that are much more comparable to the demands of aerospace. And they crash test them and fire test them out of regulatory requirements with the FIA. So, it's not that they're necessarily fully optimized, but they're definitely a place we didn't think to look until recently. And they're dealing with things like crash worthiness and fire and high energy densities and high C rates. So I think that's another place we're kind of exploring. I don't know where it'll end up, but we're trying to be creative about where we source. There are some suppliers out there that don't know they're suppliers, right? Or could be suppliers. And so, I won't mention the names of the firms themselves, but, they award contracts for the battery development for Formula E. And there was a new contract just awarded, and it looks to be pretty compelling stuff.
Yeah, the other part of this is, a lot of times when companies are building 160 materials that will last 160 degrees, but there's possibilities that if they just do some tweaks and it goes to 190, 200 degrees, that could be possibly useful for aviation. So the reason I bring up these topics is this electronic exchange platform that we're building will allow us to interact from OEMs to suppliers and suppliers to suppliers to kind of figure that out. There's a lot of give and take happens. Even Tim Cook basically has said that it's not that the design is Cupertino and just thrown over for a manufacturer. There's a lot of give and take that happens between designers and manufacturers in terms of its quality, in terms of the processing, in terms of the cost. And that's the kind of interaction we would like to see happen, particularly in the early stage of pre-certification. Once your design is firm and certification is done, we don't want to have too many interaction or too many changes that will impact the safety clearly, right? So there's no changes that could impact the safety, but we need to have this early stage design interactions, and that's the kind of thing we would like to propose, because that's when your manufacturing cost, the rate, as well as the viability of suppliers and scale for future is important. So this exchange platform that we will be talking soon in a couple of more months will be really critical to be enabling those kind of interactions and give and takes, and facilitate somewhat frictionless supplier access to OEMs and interactions with each other. Back to you, Dana.
I was going to say, should we maybe look out and take some questions?
Absolutely, yeah. I think that's a good idea. So are there questions either from here on the Microsoft Teams with raise hand as a method, or we can look up into the Conference IO. There are some good questions on Conference IO. So the first question here, I think this may be more for Uma. Where can I find the research from Airbus about the operation cost? Is there an article or any other documentation that can be looked at?
That is unfortunately not publicly available, but the answer is that it's relatively easy for anyone to replicate, right? Because it's using publicly available data on average journeys, right? And you can get a lot of information just by, using your own Google app or your own Uber app and going into it and pricing out relative costs of different transportation modes. There's a really good app called City Mapper, which allows you to put in a notional 15-minute journey, and you get the cost of every alternative that you've got at different times of day, and you can kind of map out what that looks like. And then you can make simplifying assumptions. So if you can get a cost of a 15-minute journey, you can get the cost of like what a passenger might be willing to spend on an hourly journey. And then you add some margin to that and you realize that's what the operator at scale, that's what an operator would need to charge, bake in some inflation, and you get to, a price in 2030 of a system and what that system would need to look like. And then from there, make assumptions about margin. If you just plot the best operating margins in aviation, right? You get Allegiant Airlines has the best operating margin consistently year over year in the commercial space. So they average anywhere from 16 to 30% EBITDA margin, and you can quite quickly get to the same analysis. It's not rocket science. It's just creating a framework to actually do that. It's relatively quick to do. And then what we did is we had that as a hypothesis about price, and then we validated it experimentally at Boom.
Yeah, that's great. Sort of they're doing the sensitivity analysis. That's great. I like that. The next question up, I think, David, this might be for you primarily. How do you suggest FAA rapidly approach certification of non-aviation grade parts? Interesting thought, but certainly radical rethink. Is there non-aviation, does it open up backdoor manufacturers? It says China, but I'm not going to necessarily worry about a particular country. I think it's the main point there is not how can we assure the quality and performance that's needed for aviation?
Well, something like this, in fact, we've been approached previously by other, say, inventors of different products, but they need to approach the FAA Aircraft Evaluation Group to begin, and or the Aircraft Certification Office. Once you make contact with them, they can begin to guide you whether they'll be able to handle the review of any documents or any products that they may have, or at least direct you to the current departments that would do that review. But definitely, I always recommend build up that relationship with the FAA as soon as possible, and work with those certification teams and to get a product out there. Once it gets, and again, in the commercial world, it's fairly easy, knowing that we have technical standard orders, TSOs or even mil specs to meet those specifications. But now we have the ASTM International groups that are involved in getting some standards set up, and that's another avenue that FAA may go to begin reviewing these products or even components. But again, go to your FAA Aircraft Evaluation Group or your Aircraft Certification Office to begin the process. Now, once that process begins and ultimately you get certified, then we as flight standards get involved. If, like, for again, renewal certifications, or we call it a field approval, it's a Form 337 that's used, that we were able to add this to a type certified aircraft. So eventually, when urban aircraft get type certification, we as flight standards, then we get involved in that respect. I hope that answers that question somewhat.
So what else do we have?
Yeah, so the next question up is was an easy question. I'll just answer that. Will there be a central space for companies to post RFI? And I have posted the RFI link again on the meeting chat as well as in the conference IO. So you can take a look at that and respond to RFI. It's also accessible through Agility Prime and NASA. So either one of the places you can go there and you reach the same spot. I'd love to have that. We have many now companies joined RFI through Agility Prime and NASA, and NASA FAA Agility Prime are working together. This is sort of a collaborative effort. And next month we will have another speaker from Department of Commerce. So this is going to be an all-agency, multi-agency support group here. I will take a question from the audience here in the meeting chat, the teams. Mohan, you have your hands up.
Yeah,
Go
yeah,
ahead,
PK. I'm here. I trying to unmute myself here. Yeah, this is Mohan Gupta here from FAA. David, I have not met you before, maybe sometime when I see you. I was recently at Department of Energy in the renewable energy part of DOE. And there, obviously, I worked on the biofuels for the jet, commercial jet, and so on. When we had a discussion here on battery, and when I was at DOE, we did discuss at some point about the energy requirement for the aviation for so-called unmanned air systems. And because we are talking within the context of advanced air mobility, so we are not talking in terms of a commercial jet where we have already done a lot of work there, along with people at NASA, Glenn, and so forth. So what I wanted to say is, because DOE has a very big program and a battery program and other alternative energy sources program. So I think what the community as a whole has to do is to define their energy requirement, size requirement, and the energy, energy density, size, and weight, because all those are going to be critical for the AAM enterprise. And if there are energy gaps which are currently being worked on, I think DOE might be a right place to take a lead on. So I just wanted to draw attention of the people that EERE at DOE has a bigger effort going on in the battery space. And I tend to think we did talk about at some point if the liquid fuels are also be needed for AAM, but I'm not sure what is the state of requirement or operability in that area.
I think, shall I take a quick pass at that? I think, so we've been looking as an operator at Aero, very, very interested in alternative fuels for kind of the regional use case. I think one of the things that merits more exploration in the AAM/eVTOL space, or sorry, VTOL, not eVTOL space, is the use of hybrid propulsion systems. The pushback is always, well, you have to carry the turbine and the electric system. But what if there's, what if actually the best environmental outcome is actually using a conventional propulsion system with an alternative fuel source, a renewable fuel source, right? And that for me is really interesting and something that not a lot of firms are looking at, because there's been, the Uber Elevate memo was really great at kind of catalyzing the industry, but it's kind of constrained thinking to a system that is just electric. And I think there's a lot of merit, and there should be some analysis. I'm not technical enough to do it, but someone should do the analysis around, what could you end up with a system that is, maybe not as clean, but whatever, 75% as clean as an electric VTOL with some kind of conventional propulsion system using alternative fuels. I think it's a very important question to be asked. Dana?
I think earlier this week, Saberwing announced, I think it was a $600 million order in the Middle East. And, that uses a hybrid propulsion system. They haven't explicitly discussed using alternative fuels at this point, likely because the alternative fuels are not readily available. But the legs you get, the range that you get by saying, just compromising essentially and saying, hey, we're going to use turbine to drive, and it's not, it's an APU basically, small, and use that to charge your electric, your distributed electric propulsion system. I mean, you start talking about ranges that were really out of the scope of discussion with most other battery dependent eVTOL designs, right? So I think Saberwing's use case is one of them is delivering cargo to remote areas of Alaska during the winter when the roads are closed. They have the range to do that, right? So I completely agree, right? You're not going to be 100% clean maybe the way that people would envision, but it's a great intermediate step, right? I mean, if you can do this in the next 10 years and, the fuels will come along and maybe hydrogen fuel cells come along later, but at least then you're not really range constrained the way these other, kind of the multi-copter or totally battery dependent designs are.
Agreed.
Next question, I think, is from Greg Duvall.
Hey, good morning, everyone. So today's discussion is focused on the supply chain, mainly to support the vehicle. Assume we solve that problem. Is there another, perhaps bigger challenge in the overall ecosystem that will make solving this problem moot?
Yeah, I mean, I don't
Well,
know which bigger. Sorry, go ahead, Uma. You go first.
No, I was going to say, there are a lot of other problems with the ecosystem. I don't know that there's any problem that would make, like, solving any other problem would make this problem moot, unless, like, people stop traveling completely and we live in a world of all Zoom. I still think that there's going to be a use case for an intercity transportation network, aerial transportation network. But I do think, like, when you look out at urban air mobility, I think I mentioned that most of the folks working on this problem at Airbus are doing other things at the moment. And the reason for that is, like, the problems are, enormous, right? Like, just there are maybe 10 cities in the world that can support a scale urban air mobility system today: Sao Paulo, Mexico City, Lagos, a few other cities. But beyond that, right, infrastructure is an enormous problem. One of the joys of Sao Paulo, or operating in Sao Paulo, is you land, you can take off and land where you need to go, right? We would fly from the airport to AAM and land at the top of the building, which was a hotel where a lot of us would stay, which was very convenient. But there's very few cities like that in the world, and very few cities where the infrastructure is actually scalable. So it's not just the vehicle. The vehicle's a tiny portion of the problem. The real issue is, like, bar these sort of 10 cities in the world, how do you actually scale this system in a cost-effective way? I think it's
I agree. I think there are many barriers, many problems, airspace and vehicles that will operate in urban airspace, and we're all working on it, but they all need to be addressed to make a complete ecosystem ready.
Yeah, I guess that's where I was headed with the question is, if we force rank the problems, is this the biggest one to solve first, and then we move on?
Yeah, so the way I characterize this is, this problem has three segments. One is pre-certification, and people are having trouble right now finding part suppliers, overmolding, and this, that, and other, and that reduces the cycle time for updates and design changes in the prototyping stage. Then after certification, we really need resiliency for low to medium production rates. And then after that, the economy picks up and maturity of these operations continue. We're looking at high scale. And when you look at high scale, you really need access to suppliers, which is the first stage. Second is the resiliency, but then third is the scale at an affordable cost. And those sort of three stages, each one of them has its own supply chain problems and challenges and opportunities. And that's what we are after. This is one of those things that if it's not addressed, it limits your access to suppliers and a growth. So just like airspace side and just like some other challenges we have, and they all need to be infrastructure. They all need to be addressed. They're not, it's like, do you like this son or that daughter better? It's all the same. We love them all, So we need to address them all. That's kind of the point here I think I'm trying to make. Next
Greg,
question.
I think there's another, quickly, PK, before I move off that, I think there's a really important reason why we need to think about this now. And it goes back to the story of Eclipse Aviation, which raised $1 billion on the premise of offering a sub $1 million very light jet, right? And they were able to build a prototype for sub $1 million. But when it came time to actually industrialize the vehicle, the final production cost came out at like $2 million, at which point there was no market. So $1 billion later, there's no market for the product that you can actually manufacture. And I think that's the real risk in this industry, is we spend collectively, as in, like, the investors put in billions and billions of dollars, and the people that are investing in this space are not domain experts. And they don't, like, they're kind of curious about aviation, but not enough that they're going to have multiple goes around. And I think, like, the VLJ kind of the fact that the VLJ market fell apart in the early 2000s has made a lot of people gun shy that might have otherwise made an investment like this. And so I think this time we need to think about industrialization as an industry in some sort of way that actually enables a scale ecosystem to develop early.
Yeah, it's good. That's a great example. Eclipse has been, really a successful failure in some ways, and we need to avoid falling into that trap again. Thank you for that. I think Gary calls, my good friend Gary. Gary, go ahead.
Hey, yeah, I was going to build on, I think it was Greg Dvorak's question about other big problems. And something that's been in the back of my mind through all these workshops is, kind of my thing that I always say about the future. I think when we look at these industrialized vehicles that are maturing in the market, certainly all the hardware parts of the supply chain are going to be important, but I think a lot of the value and complexity and really certification open-ended kind of questions are going to be in the software, not the hardware. And I was wondering if there's a parallel effort, or if it should be something that's part of this effort to manage that supply chain for the software development that's actually going to be these, the functionality of these future systems.
Yeah, and the short answer is yes, it is included as part of this effort because there are a lot of embedded systems and software and certification and acceptance. So you are absolutely right, but that's my answer. I'll also let Uma, Dana, and David add if they would like to. But that's a definite good perspective.
Well, it is a good point. I mean, the idea, software isn't explicitly mentioned in here, but I think we have it as implicit in things like flight controls, and propulsion, and even battery management systems. That said, I think when we talk about software most frequently with the aspiring vehicle OEMs, what they're asking us about is testing, cyber hardening in particular, right? And I think there are really two schools of thought. Some of them say, we think we're good as long as no one can have physical access to the vehicle. And then that implies a whole nother issue about where you store these things overnight, if there are going to be as many of them as we think there are, where you're going to park them. But then the other is, we're concerned about not being cyber hardened as it stands, even without physical access to the vehicle, that we think people can come in through radio links or whatever and monkey around. So through Agility Prime, we've certainly had discussions about what we can do in terms of testing, kind of red teaming flight control software, what have you, or communications, and especially to the extent that any of these vehicles are going to go through a phase where they're remotely piloted, right? I mean, if you think of this transition between piloted flight, then remotely piloted, then autonomous, right? There's going to be this middle ground, and some of them are concerned about vulnerabilities to their data links at that stage too. But you're absolutely right. There's no box there for software. We just kind of think of it as coming along for the ride in a lot of those other enabling technologies.
Any other questions do we have in the audience? Otherwise, we'll go to Conference IO. There's a good question there about helicopter parts and helicopter supply chain. Is there parallel to the current supply chain or more closer to AAM industry? Of course, they don't have wings for the rotary wing. So is there a supply chain there? And I think there are some vertical integration related considerations, probably too expensive. If we start to do vertical integration for everything, there are examples right now. I see that companies bought in a lot of machines thinking they're going to use certain type of processing, and then the design changes and that becomes obsolete immediately, and then that they're stuck with the costs and such. So a lot of interesting lessons, but any thoughts on the helicopter supply chain and what could be applicable here? from anyone?
You know, the part of the helicopter supply chain that is most applicable to this is the engineers who understand rotary wing flight, right? I mean, it's the human capital of it. I mean, there's a street fight now looking for aeromechanics specialists that specialize in rotary wing. Yeah, in terms of the physical parts supply chain, I mean, I'm not really sure that there would be a whole lot to borrow, although that certainly would be fine if there was. But I can tell you, talking to the aeromechanics people, everybody's looking for people who understand rotor dynamics and flap and all these other things, and it's distinct from the fixed wing, propeller sort of world. And so there is a run on talent there, and a lot of that talent, unfortunately, is getting close to retirement. And so that's one of the places I think that we're gonna feel stress is in the supply of rotary wing talent from an engineering standpoint.
Hello.
Okay, Johnny, I'm sorry, go ahead. Someone else wanted to add, but Johnny has a question otherwise.
Hey, hi, PK. Actually, my question really somehow relates to helicopter supply chain as well, but also linking to like general aviation type supply chain. In the past, in some cases, we really have difficulty getting anybody to supply parts because of the low quantity needs, even at several hundred airplanes a year. That's still considered too low from any other industry, particularly like the auto industry, like a generator, for example, alternator, you can get it. And you have to get through a distributor and you have to self-qualify through a testing programs and so on, approved by FAA. All that process actually adding cost to the end product. In reality, from most of the tests we have done, the product we get from the auto industry, for example, sometimes has better pass rate than our dedicated aviation supply chain. So is there a way that we can leverage, I'm jumping around, but think about Robinson Helicopter. They are producing at a fairly good rate of product deliveries on an annual basis in a good year. Can we learn something from that and leverage that kind of supply chain thinking? And is there a way that we can leverage non-aviation supply sources, but with a lower cost qualification process? Thanks.
Sorry, my internet cut out at kind of a critical moment. PK, could you re-summarize Johnny's question? I think I have a view on it, but I want to just make sure I'm clear on what the question is.
Yeah, maybe it's best, Johnny, if you just maybe can re-ask in a couple of sentences. I think you gave a lot of background, and I think maybe better to just.
All right. Yeah. Well, basically, I'm thinking that if we look at the general aviation, including the piston helicopter production rate, at least that get us to the initial run of the eVTOL production category. And we do leverage sometimes non-aviation suppliers, but the qualification process really add a lot of cost to the product. May or may not be increasing the quality level per se. Is there a way that we can, for eVTOL industry to flourish, is there a way that we can leverage non-aviation supply sources without make the end component 5 times the cost of non-aviation use?
Yeah, so basically what you're saying, John, yeah, go ahead, Uma, but what I was going to rephrase it. Yeah, go
And
ahead.
I was actually just going to answer it because I think that's actually exactly the question, Johnny. I think if you look at Robinson, right, they've been very good at building and maintaining vehicles at a cost competitive price, like what we believe the ultimate end operating cost of these vehicles need to be for a system at scale. The issue, however, is one of redundancy, right? And I think because helicopters, fly so little and have historically been designed for lower, they're not designed to 10 to the minus ninth, right? I think they're designed to like 10 to the minus 5 system redundancy, apparently. And the thing is that as such, helicopters are perceived as less safe. And I don't think we can have a system at scale that is perceived as less safe than commercial aviation. And so the question is, how do you get redundancy how do you get redundancy and cost efficiency in the same platform? I think that's something that we don't fully know the answer to yet, because with redundancy comes complexity, and with complexity comes cost, typically, right, to get to commercial aviation levels of safety. And so I think that is the objective, and I think that's what everyone needs to be thinking about. But I don't know I don't know what the answer is, and I think that's probably an FAA question, which is like, how do you
It definitely is a fair question, but here is one slant I can offer you. The challenges that current industry had when they allowed the supplier or the parts that were not quite standardized or certificated or such is that there is no way to assure the quality. So unless we are able to really say that these are the 20 parts that doesn't matter, standards are not needed whatsoever. They can be anything to assure the quality of operation. So we have seen some fake parts, that bolts and nuts and that aviation grade parts, couple of $100, and then the cheap parts are, there's an incentive to do fake parts because these parts really, if they're not aviation grade in terms of their temperature tolerance and capabilities for forces, they can be really cheap, a couple of cents, and you can make a lot of profit by selling those. And if there is no performance requirement, then that makes sense. But I think this is where I think work needs to be done to figure out which parts would require performance requirements. The other part of that is which parts can be standardized. So Dana gives this example all the time that if you go to the gas station, you want to pump into your car, that nozzle doesn't need to be basically uniquely designed for every car. It can be standardized. Now, standardization in some cases reduces the cost. Most, I should say, all cases would reduce the cost. So that kind of standardization might be a way to reduce some of these things as well. So there are many dimensions of this to try to look at exactly how to standardize some parts, or to look at where we can get away with not having a clearly articulated standard, which may not tinker with safety or performance, and that is the type of analysis we'll have to do, to understand that. But I know, David, your hand is up to answer, so please proceed, David.
Thank you, PK. Yeah, you actually you're right on the money on that. If I understood the question correctly, that if a supply chain can't provide the parts, components, or whatever is needed, can an alternative, say, source be used? And the answer, the quick answer is no, unless that source has already gone through the process of being certified, so its parts and components are considered can be installed in an airworthy aircraft or a type certified aircraft. If an uncertified part gets installed on an aircraft, then that part is considered by the FAA as a suspected unapproved part, which then invalidates the type certification of the aircraft, which is then the aircraft is considered unairworthy, because we don't know how that part would react in flight after X number of hours of or cycles. So that's why we don't use parts, components that are unapproved. Once it goes through the approval process, and both AEG or the Aircraft Certification Office, and also the Maintenance Review Board, MRB, as we say. If all those have been approved, they approve the part, then it could be considered as a airworthy part that can be installed on a type certified aircraft. So that's the quick, the quick answer to that.
I guess my question was, in the past experience we went through, especially with the eVTOL, many of the eVTOL design with a lot of fail-safe features and redundancies and so on. Is there a way that we can look at the overall integrated design build process such that it determine the criticality of major individual components? Not every part to be a 10 to the minus 6 level, or everything goes through the standard FAA qualification process. The reason I'm asking that is I'm trying to come up with the methodology to control the resulting total vehicle cost and system cost. The traditional qualification, once we go through the standard FAA qualification parts supplier, everything costs money. That's why, aviation qualified parts, even if it's the same part, a lot of time costs 4 or 5 times as much as a standard part, even if it's the same part, but goes through the qualification process and the MRB procedures and all that. Every time somebody touches a piece of paper, costs money. And I'm not saying I have a solution. I'm asking the question, can we step back and look at this eVTOL revolution? Do we have a way to reset our mindset and approach the thing in an intelligent way to flourish, to nurture this industry so that it didn't fall into the same cost trap, I call it, I'm sorry, but that we're currently facing with. And that's why even the current Cessna 172 costs so much to buy a new one.
Well, I'll give you an example that I'll go to the general aviation world. There's been times where an alternator, they're trying to find a different alternator to install onto, say, Beechcraft aircraft, and it's an automotive component. So it hasn't gone through the process to see how it would react in the national airspace after X number of cycles. So because of that, that component, it could be even the exact same component, but since it hasn't gone through the process, we don't know how it's going to react in the national airspace. That's why it has to go through the certification process and testing to see what it would do. Sometimes there's been situations where they try to do it under what we call a field approval to install it on the aircraft. But again, if that part or component hasn't gone through the initial certification process, we don't know. So we can't allow that kind of installation to occur. So you can go through the process of certifying the entire system, but that means all the parts and components that exist on that system, on, say, that urban aircraft, would have to be functioning. That'd be like the type certification. You couldn't add additional parts or components that to make it fly. Again, each part and component per the FAA would have to go through the certification process. And again, that's the AEG, ACO, and then also the MRB groups. We as flight standards, if we get approached, say, on a type certified aircraft, and they say, can we install this part or component onto the aircraft, we would have to go through the evaluation process and then present it to the AEG as well as to the ACO and say, can this part or component be installed? And they would give us our feedback. If they would say no, then the applicant would have to go and go to the ACO and go through the certification process.
All right, we're running towards the end now. We will take one question from David, Matt, and then we will try to close it quickly. David, do you have a question?
I had one comment. As we look to reduce cost for the build out of AAM, I think it's important to note, and especially to Johnny's question, it's about risk mitigation, and the cost comes from RDT&E, the certification, automation build out for these parts, as well as testing and evaluation design. We mentioned previously the engineering qualifications necessary to design and build out these parts. And I'll quote James Wang in his brief last week, or was it the week before, in his eVTOL class. He said it would take $1 billion to come from a clean sheet design to build one of these aircraft. That's just where the system is right now. As we look to reorganize the supply chain, I thought the documentation was pretty right on. And then Dana, to your point, I think what's needed is strategic patience as we, the supply chain, kind of maneuver out of this commercial air suppression, where it's left a great void. It's impacted everyone in the supply chain. So it's a good time to have that tactical patience, I think, do risk assessment. And as we develop automation in the aerospace industry, that will reduce cost for you overall. So I think the patience is going to take some time.
With that, I would like to close, and we just want to offer a few more information here. The next topic up is standardization in November 12th, which happens to be my wife's birthday. And then December 10th will be electronic supply chain platform. We'll have something really exciting to start sharing for community's benefit, and then modeling simulation environment we are building. So we have a lot of exciting things coming up that will continue to help as we maintain the strategic patience here, but we are getting ready to try to help. And I will be talking about different phases of supply chain maturity, sort of S-curves next time. We continue to ask you to send any comments and criticism and feedback, good, bad, ugly, anything on that email at arc-cal-nari. We learn, I keep saying this, and I'll say it again, we keep learning from our critics as well as basically well-wishers and supporters. We want to learn, we want to do better. This is for community. This is not just for us, for David, Dana, and I, but we definitely want to be respectful of your time and offer good opportunities for interactions as well as building up. We greatly appreciate Uma's time today and her wisdom and years of a variety of experience. I think she's one of the rare executives in the aero industry with a wide range of experience in the conventional setting, new startup aero, as well as different angles from beginning to operations, beginning of development to operations. So I think we were really thankful, Uma, again, for your participation today. And I want to also thank our NARI team, Brianne and Ashkan, for running the logistics to help everybody. And we will see you at our next meeting on November 12th.
Thanks.
Bye-bye, everybody.